who were expecting pragmatic privacy with liminal, I hate to inform you that the title in the agenda was slightly outdated. So if you want to leave, I won't be offended. Instead, we're going to do something that's probably useful for prospective participants of the hackathon. So like a very basic introduction to smart contracts in Ink. We've just seen Go. Now it's time for some Rust. Go, modern languages. Okay, so yeah, I always include this definition of a smart contract, but it's not really useful. It just looks good on a slide. I think of them basically as programs executing on a computer, and the computer just happens to be a blockchain. You know, but once you're able to program blockchain, you can unlock a whole array of very interesting use cases. You know, DeFi, digital identity, and many, many more. So it's really a very, very powerful thing to learn. And having said that, it's, you know, it's like I think it was in the Spider-Man movie that with great power comes great responsibility. And true, you can program a lot of very interesting programs, contracts, but those seemingly innocent and simple pieces of code, you actually need to be very diligent in how you actually write the code, and it needs to be written with great care and with a lot of focus on safety. And well, to that end, I'm actually a big fan of using languages that kind of have the safety, if not built in, then at least, you know, they don't allow you to shoot yourself in the foot as easily as other languages can. So Rust is a good example of language that's, you know, it's modern, it's backed by some research. So it's very predictable and actually allows you to express a lot of constraints in your programs so that you don't have to catch your bugs in production or on the mainnet. Instead, you can do it, you know, with the help of your compiler and test suites. So we're going to be deploying this well, working towards deploying on the Aleph Zero blockchain. So if you're not familiar, we're a layer 1 proof-of-stake blockchain, well, nominated proof-of-stake actually, with some focus on privacy and great performance. So the block time and time to finality are both sub 1 second. And what's quite cool for smart contract developers, owners, is extremely low transaction costs. So A0 is, well, roughly around $1. So yeah, this is virtually free, actually, in the current landscape. And well, of course, we feature smart contracts in Ink. And you might ask, what is Ink? Well, oh, I'll get to that in a second. First I wanted to present a few useful links. If you scan the QR code, it just takes you to the main landing page, the first link. But if you're starting to learn about substrate chains or about Aleph Zero specifically, or Ink development, then these links should get you started quite nicely. So the first one is our main website, and actually, you know, you can, with just 1 or 2 hops, get to every other link. The second link is our documentation, and is actually not only for smart contract developers, also for validators, nominators, general users of the chain, and anyone interested in how it works. But of course, smart contracts are there, and actually also a cool security guide that Kudelski Security wrote. Some interesting stuff there. Also the developer portal, which is like a hub for developers. Then the testa0.dev is the testnet developer wallet. So of course there are several wallets, but this is the one you would use as a validator, for example. Then, of course, the contracts UI, and for the programmers among us, you don't have to use the UI. You can, of course, do it all from the command line, but sometimes it's convenient and definitely looks better on slides, so I'm including it here. And the question we get asked all of the time is, okay, I have the smart contract now, how do I talk to it from my app? And well, the last link basically answers that. There's this API in JavaScript that you can use to talk to the chain, make transactions, query the chain. So that includes talking to the smart contracts. And of course, there are libraries in other languages as well, Rust, Python, you name it. Now, okay, I mentioned Ink several times already and didn't explain what it is. So Ink is not a separate language in a sense that it's actually built on top of Rust. So it's actually a subset of Rust with some additional macros and convenient features targeted at smart contracts development. But by virtue of being a subset of Rust, it has all the goodies that Rust has. So, like I said, a modern language, a type-safe language. I always say it's as type-safe as you can make your language while still making it usable, for developers. Because anything more, in my experience at least, because I come from the Haskell development community, anything more type-safe generally tends to be quite tedious to write, and also tedious to make it, run really fast. Rust is also memory safe. Also, actually, in contrast to Go that we've just seen, it's a different approach. So Go goes like the garbage collector approach. We go Rust goes the kind of smart pointers approach, but has all this nice ownership concepts. You can see how it can make a completely memory safe program with zero overhead. The tooling is generally quite nice, and it's winning the Stack Overflow developer surveys like crazy, so probably a good thing to learn in 2023. Now, Ink, Rust can compile to different backends, and then it includes WASM, which we use for smart contracts. So this is WebAssembly, and you probably all know it. It's pretty ubiquitous. It's also fast and secure. It runs on pretty much everything. So yeah, this is what it looks like on a very high level. And of course, one of the questions you might ask is, okay, I'm coming from Solidity. How do they correspond? And while they are, different languages with maybe different philosophies a bit, actually conceptually, you will feel quite familiar. So this table is not there for you to really analyze, but it kind of shows the one-to-one mapping of concepts, right? So pretty much everything you can do in Solidity, you can also do in Ink. Well, the syntax is maybe slightly different, and yeah, like I said, the philosophy might sometimes be different, but you'll feel familiar after a few contracts that you write. Now, this is, I know this is a wall of text. Again, I don't really, want you to analyze it that diligently, but this is more or less what your onboarding flow looks like for Ink, right? So first you install the required tooling. And this was done on Ubuntu, but you can also install it on a Mac. On Windows, yeah, it's a bit tricky, but should work. So some prerequisites, including, of course, you need Rust and some libraries for optimizing WASM. And once you have Rust along with Cargo and Cargo Contract, which is, Cargo is basically this build tool / package manager / management tool for Rust. We also have an extension for writing smart contracts, so you need to install Cargo Contract. This is the last line here. And once you have it, you can bootstrap a new contract, similar to what you would do in a Rails app. And this gives you a basic flipper code. And this is actually kind of nice because normally I would tell you to focus a lot on how the macros look and everything. But to be honest, you don't really need to, because it's always going to be there as a starting point. So it's good to know the overall structure, but not the exact order of characters or something like that. You'll have that written out for you, the structure, and you can focus on the logic, which is quite nice. Then you test and build your contract, and what you get is, the WASM blob, so the actual binary, the contract's metadata, which is quite important because you cannot really tell a lot about the contract just looking at its binary code, even if you decompile it to human-readable representation of WASM. The metadata is also sometimes called an ABI. It's basically what you can use to, it's kind of like doc strings for the methods, actually, and also some information about where they are in the bundle and everything. And for convenience, the two are bundled together so that when you actually deploy the contract, you can use just one file, which is a nice touch. And now, something I've decided to include is, this is a pretty new and dynamically changing ecosystem. So sometimes, and this especially should be important for those of you who are planning to take part in the hackathon. There's a lot of moving pieces that you need to get right in order for this to work. So your mileage may vary, but this is the combination of versions that works for me. And so yeah, so Rust 1.69, and you might also want to install the nightly toolchain. Like this. Cargo contract 301, and there are newer versions right now, but I feel confident using this one. Now, to run your contracts, even for local development, you can do it in a number of ways. I'm going to show you a cool one at the end, but one of the recommended ways to bootstrap it really quickly is to get yourself an instance of Substrate contracts node. So, you just spin up a very small local blockchain made of one node. And the version I use to good effect is 0.26 and Inc. 4.2.1. And now this is, this is actually an important piece of advice that we've learned using our own experiences. This is a line taken out of the cargo.toml file that you use to specify the versions of your dependencies. If you're putting the Inc. dependency, you might want to put it with the equals sign in front of the version so that it chooses the exact version that you specify. Otherwise, on different installs, Cargo will try to choose the newer versions, at least with the minor version, and the patch version will possibly change. So it's actually really convenient to fix it on a specific version down to even a patch version. So yeah, piece of friendly advice. We're going to take a look at how the contracts are deployed. On purpose, I'm not doing any live coding, just because I've learned my lesson a few times. Something always goes wrong. So yeah, and I choose to present the concepts by doing an ERC20 or the PSP22 spin on an ERC20 token. So like your regular garden variety fungible token. And I'm calling it Petecoin because I thought it was funny. And well, I do quite a lot of these presentations, and someone actually already made a Petecoin, and I think even on the mainnet. So they kind of stole my joke, but it's okay. Yeah, so what is ERC20 or PSP22, as we call it in the Substrate ecosystem? Well, it's basically an interface that your contract needs to implement in order to be viewed as a fungible token. So there are some basic methods like total supply, basically how much of the token is in circulation. Balance of a specific account, it needs to know that. Allowance, I'm going to mention allowance later, but for now I'm just going to focus on the transfer functionality. And of course, the transfer method, probably the most important one, is basically, you can transfer some of your tokens to some other address. And yeah, and contracts are emitting events. We are going to come back to that later. So yeah, let's dive right in. So when you start creating the contract, like I said, this is going to be created for you, but still, it's nice to know what this means. You start with the flipper, but you start inputting your own logic. So at least it's useful to know what not to change or delete. So the things with the hash or the pound signs are macros. They are not comments for those of you coming from Python. The line at the top basically tells the compiler not to include the standard library because the Inc has its like own prelude with some primitives. And the second macro is actually a very important one. It tells the system, the compiler, that the module written below is actually a smart contract, and it actually enforces certain invariants. Now, the module declared with the mod keyword is actually somewhat similar to a namespace in C++. So there's no like magic going on with modules like you could find, for example, in Python. The modules are more or less a collection of things gathered under a single name. And you can import stuff into the scope of your module. So if I do use Inc storage mapping, then I'm bringing the mapping name into scope, and I'll be able to use it starting from this import. You can also like re-export stuff by writing pub use, but it's beyond the scope of this presentation. So yeah, this is like pretty much the invariant that every contract has. Now, the most important part. So every contract needs some form of a storage. Well, actually, you could, in theory, create a contract without the storage, but or maybe, I'm actually not sure. If someone is on the computer right now, you can check if you can create a contract without storage, because I think one of the things that the contract macro does is actually enforce the invariant that a contract needs to have exactly one struct marked as storage. Now, there's quite a few things happening here, especially if you're not used to Rust. First of all, there's the Inc storage macro that does some magic, but more or less what it does is instructs the runtime how to structure the memory on chain once you upload your contract, and the details of the memory layout of the contracts are way beyond the scope of this presentation, but you can read about them at the use.inc site. It's actually a very nice piece of documentation. Now, what we're doing here is declaring a Rust struct. Well, we're prefixing it with pub to just say that it should be accessible from outside of our module. But a struct is like an object in any object-oriented language. Well, sorry, kind of like a class. So if you're familiar with C or C++, it's very similar. Although the Rust structs, you cannot like declare behavior inside of the struct, which is a very cool thing. You cannot inherit from the structs. They're just basically a box for stuff with fields that you can access by name. So yeah, that's pretty cool. And inheritance, well, yeah, this may be controversial, but I think inheritance is generally not a good thing to have in your programming language. I'm happy to discuss that after the workshop, but I think Rust's choice here is great. So yeah, you have this struct, and it has two fields: the total supply, which will be the balance, and balance is like the Inc's built-in primitive. It also has the balances mapping. The mapping is, well, think of it as a hash map, or like any map, like a dictionary in Python. So this mapping will map from the accounts to the balances of these accounts. So this is kind of like a ledger, or, well, not a ledger, like a balance sheet of all of the users of your contract. And importantly, if someone hasn't interacted with your contract and didn't get any transfer, they will not have an entry in this mapping, right? But if you send them some tokens, they will get an entry. We'll see about that later. And then there's the derived default line, which it's a macro that will basically create a default implementation of this struct for you. If you're familiar with like the concept of a monoid, a good default implementation would be like a 0 of the monoid for each of the fields. So if you have like a number field, it's probably 0 as a default value. And if you have like a collection, then an empty collection is a good default value in case you ever need to implement it yourself. These are the basic guidelines. Otherwise, it just becomes confusing. Now, I said that Rust structs don't have behavior attached to them, well, inside of the struct. That's true, but you can like add certain methods to the struct outside using the impl, short for implementation, I guess, or implement, in this block. And yeah, so the methods that we declare here, you will find them familiar from other object-oriented languages that you might be familiar with. But the first method that we need to have, and it's a special one because it doesn't have self as the first argument, it's going to be the constructor. And one of the things that the inc contract macro enforces is that your contract needs to have at least one constructor. So the constructor will be basically any method that you mark with the constructor macro. And it doesn't need to have any special names, right? So it doesn't have to be like init or new. But note that the users of your smart contract will need to call this method to create your contract if they want to instantiate it. So it's good if, if it has a fairly intuitive name. Now what this does here is essentially create an empty mapping for the balances, check who's the caller of the contract by calling this magical self env method and then calling the caller method. So this gives you the address of the account that is calling this contract right now, right? So if this is the constructor, then you're the one instantiating the contract. So this caller here, and hence the contract owner. But for other methods, the caller might be someone entirely different. And what we do here is we take the balances mapping and insert to it the pair of the caller, so the owner of the contract in this case, and the total supply, because initially the owner gets the whole supply and then they can make transfers to other accounts. And yeah, and we basically create the instance of our storage struct. Note that in Rust you have this like concept of an implicit return. So the last line will be returned unless it has a semicolon at the end. But here it doesn't, so it just gets returned. Yeah. Now, you've... Yeah.
First question, we have total supply with this strange character.
Yes.
Why?
It's a reference or like borrowing, and next slide is actually about that.
And the second question, mapping keys like in Solidity. So we don't have the keys, or like in Java, so we have the set of keys.
Yeah, it's like a keyed mapping.
Okay, thanks.
So yeah, so the ampersand. So to understand what it is, we have to take a step back and talk about Rust's memory management. So basically how this works is you have this ownership model. So everything you allocate on heap has exactly one owner. And yeah, well, I'm just reading the slide now. You cannot access a piece of data unless you own it or have been borrowed it, right? And what this means that, well, it might seem weird. Well, what does it mean that you don't own it, or who's the you here, right? And it's actually like scope-based. A certain scope or like a function or a block of code is the you in this case, right? So this is cool because this is a model of memory in which, well, you have like all of the safety guarantees, but Rust is able to check all of this at compile time and hence not induce any runtime overheads. Now, you have two ways of essentially transferring the ownership of a given value, of like a piece of heap allocated data. So one is move, and again, those of you familiar with C++, you probably know move semantics. So this is kind of similar. And moving happens when you are passing by value, so like just, passing your argument to a function, or you are assigning. And moving means that you are no longer in ownership of the data. So if you pass it to a function, now this function becomes the owner of the data, and you can no longer access it, as we're going to see in just a moment. And the second way is borrowing, and this is very similar to passing by reference in C++. Now, let's look at this example, right? So I have a struct with just one field. It's some number. And now I have this function that takes an instance of this foo struct by value. So, and just tries doing something like returning the struct's field with, incremented by 1. So now what I do to test how this works is I create this struct. Then I pass it to a function by value. So remember what I said, that we no longer own this foo struct once we've passed it by value. And then I try accessing the field of this struct. And what do I get? I get an error, which is actually quite descriptive, because the compiler pretty much tells you what's happening and how to fix it. So it basically says, OK, you no longer own this value, but you're trying to access it. So something's wrong, right? And indeed, the compiler even tells you, what are the exact places where the problems occur. Now, how to fix it? I can say, OK, instead of just giving away the foo struct in this line here, I'm going to borrow it to the function. The function will do what it must, and then it will return the object to me so I can access it. But notice that I changed the implementation a bit, because right now I'm not returning the value of the field. I'm just incrementing the field by 1, right? It's a super simple operation, and yeah, seems like it could work. And this is to answer your question. This is what the ampersand means. So first you use it in the declaration of the function to basically let the compiler know, OK, this value will not be passed, will not be moved, it will be borrowed. And in the actual call, you also say, well, don't just move this value here. Instead, borrow it to this function. And it needs to happen quite explicitly, because otherwise you might do something that you didn't intend to. And this way, if you're intending to borrow this instead of passing by value, you need to be explicit about it. So it actually reduces the number of errors you can make. So OK, this should work, right? No, not really. And that's because Rust is quite conservative in what it lets you mutate, right? So it's a pretty well-known fact right now that mutating the state pretty much is a pretty dangerous operation. So Rust basically says, OK, if you want to mutate some state, you need to be explicit about it. So how are we going to fix it? Well, we're going to say, OK, so this pass by reference function is borrowing this foo struct, and it's borrowing it in a way that will mutate it, right? So, if it actually makes a lot of sense to me. If I'm like borrowing a hairdryer from someone, I usually don't like tinker with it. And if I am, I'm going to let them know. So this is what Rust is doing here right now, right? And we also need to be explicit about the mutating part in the actual call. And now it all works. And the question, like homework, is OK, this makes sense, but what if I'm trying to like return a borrowed value somewhere else, right? You lend me a hairdryer and I'm just giving it away to someone else. What do you do in this case. Yeah, it's an interesting problem, and Rust has a nice way of solving it. You probably will never have to use it in a smart contract, so I'm not including it here. I encourage you to do some research. Now, getting back to the contract. Okay, we have the module declared, the contract declared, the storage declared, the constructor declared. Now, our contract needs to be able to answer some calls from the outside world, right? So, again, this is something enforced by the contract macro. You need to include at least one message in your contract, which will be a public method taking self as a reference. This is actually very similar to Python, but the messages need to take the self as a reference and not by value. And it needs to be marked by the inc message macro. So now the first one we define is the very simple total supply, which is just a getter for the total supply value. And if we declare it like that, someone can go to the contracts UI, import our contract, and call it paying some small gas fee and learn the total supply. Now, the other method is actually, it's very simple, but it's actually very interesting and showcases some of the very elegant parts of the Rust philosophy. So let's say we want to learn the balance of a certain account of our token. So what we do is, okay, we have this balances mapping, right? And we can get a value from under a specific key. And now the usual problem here is, well, what if this key doesn't exist in the mapping, right? Well, to like solve this, the get method of the mapping doesn't return the value, a concrete value. It returns a wrapper called an option, which may be something with a value or maybe nothing. And now we can call this handy method unwrap or default, which is saying basically, okay, if there is something in the box, just return it. If there is nothing, return the default value for that type. Of course, the type needs to have a default implementation. We've seen how you do it before. And this is actually extremely convenient for our use case in which if someone is not in our mapping, in our system, they don't have an entry, right? But here we return 0 as their balance, which is actually true, right? It tracks with the whole like banking analogy. And we're going to see in just a minute how it's used to actually make a transfer to someone that doesn't exist in the system yet. But basically, this is the Rust way of handling, well, non-determinism, right? It can return something, it can return nothing. We handle it in like an algebraic way. Now, I just like to include this graphic. It's extremely simple, but how do you make a transfer? Well, we have Alice, who has a balance of 1,000 coins, and she wants to transfer 100 coins to Bob, who also actually happens to have 1,000 coins. So she calls our transfer method with Bob as a recipient, with 100 as a value. So what do we do? Okay, we first need to check if Alice has enough of the coins. If she does, we subtract the transfer amount from her balance, and then we learn the balance of Bob's account and increase it by this amount. And yeah, just like that, the transfer is done. And now Alice is left with 900 coins, Bob with 1,100. And it's pretty cool because this is, where our returning 0 if someone is not in the mapping comes in handy. But yeah, let's go through the code. So don't worry about the boilerplate here. Basically, the transfer is to an account from the caller, and we use the wrapper here to make it a bit faster actually, because WASM is good at references. So sometimes it's good to convert something to reference. This is outside of the scope, but yeah. So So first of all, we check the balance of the sender. If it's insufficient, note that we don't throw an exception. We just return this error. I'm going to talk more about this way of error handling. Then we decrease the balance of the sender by inserting the previous amount with the value subtracted. Then we check the balance of the recipient and insert, well, their balance with the transfer value added. And we emit the event. And if everything went OK, we return this OK. And now notice that if in this picture Bob was not present in our system, then the balance of implementation would return 0, and it would actually all work. And it's super simple and super nice. Now, you've seen this return error and something like that. So this is a part of a larger concept of handling errors in Rust, which, yeah, coming from Haskell, I love this. This is how you should handle your errors, definitely. So the way you handle errors in your contract, but also, well, in general, is instead of throwing exceptions, which are, by the way, just a glorified goto, mark my words, you do this custom error type, and you basically list all of your error cases, and they are structs themselves, like enum variants, but you can put basically any information you want inside of these errors. We here don't really need additional information in case of some of them, but some of them do require some additional description. So yeah, once we have this error, we also need this type similar to the option type that we returned from the mapping while getting. So we have this result that has two variants. It can be one of two things. It's called the sum type, by the way, I believe. So it can either be an OK, which is like the happy path of the computation, and then it carries inside the actual result of this computation, a value. Or it can be the unhappy case, in which case it carries some sort of an error message. And don't worry about the scary looking type markings here. It's just, this just goes to say that this can be pretty much any type you want it to be. And yeah, you can also, if you're, for example, always using string as your error message type, which you probably shouldn't, but it works well for the example, then you can make like a type alias using the type keyword. And one thing to note, that the type keyword is not type checked. So whether I write my error of t or my result of t and string is actually the same type, right? So there are some ways to distinguish types like that, but the type keyword is not one of them. And yeah, this is actually pretty cool because you can now return your errors, and it's up to you how you handle them, right? You can basically blow up your whole computation when you get an error, but you can choose to handle it in some graceful way, and it's good because it basically puts all of the control of the error handling in your hands, and most importantly, doesn't interrupt with the execution flow, right? So if you have, like, imagine, I don't know, nested for loops. If you throw an exception, it just cuts right through all of the executions, unless you catch it, but you might forget to, and so on. And here, it encourages you to structure your computation slightly differently and handle the errors more purposefully. So I guess it's a great concept. Now, the events is basically a way of letting the outside world know what is happening inside your contract. Oh, I didn't read the slide, but I just repeated what's here. Well, it's OK. So for instance, you might have a contract explorer and someone uses it to, or like a web app, and you want to use it to, display the information about someone's account, what happened, and so on. Similar to what you get in your like Web2 bank app. You get the old transfers and everything. So we can do a similar thing here, and our code can emit events. And events, in essence, how you declare them is you make yet another struct with a macro. You should get used to it by now. The macro is inc event, unsurprisingly. And well, you can put pretty much arbitrary fields in the event. What you can also do is mark certain fields as topics, which basically will allow the event ingesting system to like index these events based on this topic. So for example, here a good field to index on would be the the senders and recipients of the transfers, because they should be pretty like discrete and unique. The value wouldn't be a good field to index on, right? It's actually very similar to an index on a regular relational database, and pretty much same do's and don'ts apply. Now, a question would be, so this event basically tells us, okay, a transfer happened. And notice that we mark the from account and to account as optional, right? So a question to you would be, can you imagine a scenario in which we make a transfer but it has no sender, or a scenario in which we make a transfer and it has no recipient?
We want to anonymize it, for example.
In this case, probably the recipient would be something like a mixer or something like that. So, okay, yeah, the answer is you probably, in some cases, want to mint and burn coins. So minting coins is basically a transfer with no sender, but with a recipient, and burning coins is a transfer with the sender, but with no recipient. Burn is kind of like, sending to dev null or something like that. Yeah, so this is the way to emit events, and this is like the standard way. If you dig deeper and if you want to write like multi-contract settings with cross-contract calls, you will need to handle your events slightly differently, but that's a part of a larger discussion, and I encourage you to check out our examples in the on the Aleph Zero websites. There will be some information about it. Yeah, so like I said, the option type, you see that this is called an option type. It has the some and none variants, similar to Scala, I think. Scala uses the same wording. Of course, you use the self-env. You've seen this method, I think, once or twice already in this presentation. And oh, and if you feel surprised by the asterisk here, it's like an opposite of the ampersand, right? So you can take a reference to something, and you can actually take the something from the reference and dereference it, similar to C++. Yeah, so now a cool feature is that you can mark your messages as payable, and this will allow the callers of your methods, well, sorry, messages, as we call them, this will allow them to send some of the chain's native currency along with the transfer. This is cool because you can have, like an, I don't know, NFT minting method that will require you to pay it a few A0 in order to mint your NFT, right? So this is a good way to collect fees or take deposits. Yeah, and the way to access, well, the value just gets, added to the contract's balance. And oh, by the way, note that a contract is also an account. It's kind of a special account, but it has a balance just like any other account. And the contract can also make a transfer on its behalf. So there are, the important thing to distinguish is that we are talking about two kinds of currency here, right? The one we're talking here with payable is the chain's native currency. And all of the coins we were talking about in the previous slides were the currency we are just creating, right? It's like a lot more virtual because we are just maintaining this mapping. And what's also important is that while the chain's native currency is, is secured by all of the cryptographic goodies and hashes and validators and everything, basically what you write inside of your PSP22 contract, then that's what you get. And the chain cannot verify that your logic is correct, right? So you need to be quite careful here. Yeah, so once you have the general structure of the contract, it's good to write some tests. And I'm not gonna dive very deep into the tests. Just know that they exist. Actually, in two flavors. One is unit tests. So like their functionality is pretty limited, but they're fast to write and good for verifying like the very basic building blocks of your messages and your contracts. And you have end-to-end tests, which are quite a new addition, but they allow you to test like the full execution of your contract. Yeah, more on that in a second. Oh, actually, worth mentioning that in the PSP22 standard, or the ERC20 for that matter as well, you have the approve method and the transfer from method, which is very useful when creating like exchanges and other kinds of DeFi protocols. This is basically a way to allow someone to transfer your coins on your behalf, right? And so there's an additional mapping involved saying who let who transfer how much, and then you can transfer on someone's behalf. It's pretty cool. Yeah, so a small bonus, because, well, at least my like knee-jerk reaction to seeing all these algebraic errors would be, damn, that will be extremely tedious when I have multiple functions returning multiple errors. Won't this just turn into a huge ladder of if-else statements, or like pattern matches nested 7 times? Well, it would, but we have this nice well, syntactic sugar, or yeah, how do you call it? We have this question mark operator, right? So imagine we have, well, essentially we have 3 functions. So one is a computation that might fail with error 1 as the unhappy condition. Another function that might fail producing error 2. So, if we can handle it the brutal way, saying, okay, if the first one failed, then just panic, kill the whole program. And same thing for the 2. We can try to pattern match like different combinations, right? There's 4, but we can do this. We can say, okay, let's make the top level function return some more general error, and we will provide the conversion from error 1 to this general error, and from error 2 to this general error. And now it will basically look like this, right? You might have actually seen similar stuff in JavaScript, but here it's like based on these implementations of traits, and then you might think, okay, but won't this be even more tedious when I have to write the conversions? Well, no, because first of all, the conversions can be really simple, and second of all, in like day-to-day usage, you're rarely creating your custom errors, and usually all of these error structs will just have these conversions implemented. So in essence, this just starts looking like, regular imperative code, but with the question marks, so you know that it might fail, and there's full type safety, and I think it's pretty cool. Yeah, so once we created this, we can deploy this on chain. Again, no live demos here. I've learned my lesson a few times. Yeah, so we have this contracts UI. Again, you can use a CLI and cargo contract to deploy your contract, although I think for a workshop, it's way more spectacular to showcase the graphical interface. So I choose an account that I will use to deploy this contract. Of course, I have either like a development version of the Aleph Zero chain running, or, well, I can deploy to testnet, although I don't really recommend, if you're tinkering, deploying to testnet because, well, it's public. So probably better to start experimenting on your like local instance of the chain or substrate contracts node, or stay tuned. Now I need to give the contract a name, of course, and upload the contract bundle that running the whole cargo contract build gave me. And it's gonna get verified, like if it makes sense, and that, checksums and everything. Now, it's actually a 2-step process, but the UI makes it look like it's almost a 1-step process. But first you upload the contract to the chain. It gets like saved to the chain, it gets a code hash, and then you instantiate the contract, which basically means calling its constructor and actually creating the storage struct and everything. So yeah, our constructor is pretty simple. I choose what's the balance that it will start with. So sorry, the total supply it will start with. There's some parameters that I can change, but don't need to talk about them now. But there's this really cool thing that it does is before the instantiation, it actually performs a dry run. So like well, you can think of it as simulating the run, but it actually just doesn't modify the storage in any way. It just runs it, and this will tell you, how much you will pay in terms of gas fees and everything. Now, once you do that, you basically get your contract on the chain, local or not, and you can interact with it. And in the UI, you can. Of course, you have the Interact tab, which will allow you to choose the method and like interactively fill the fields and everything. You can also view the metadata. Like I said, this is constructed actually using both the code and the doc strings you put in the code. So actually, it's super important to write good documentation for the contract. So yeah, you can see that this roughly corresponds to what we've written. Yeah, this is basically us calling a basic transfer method. Here I have another test account that I can send some coins to. I can then, of course, verify that the balance is changed accordingly. Yeah, there's a log of the events. So this is more or less how you use it. Now, if you're starting ink development, or actually if you just want to move quick when developing, my recommendation for the hackathon and beyond would be to definitely check out Inkathon. This is like a boilerplate for a whole dApp, so including front-end, back-end, and smart contracts, actually created by Dennis from A0 ID, one of our ecosystem projects deployed on the mainnet recently. You should definitely check them out. They're an incredibly cool project. And Inkathon is written very well. So it should speed up your development. And another thing, oh yeah, there's a video. So a friend of ours from Cardinal Cryptography made something called Drink, which is basically, I somehow cannot make it full screen, sorry, I'm not good at computers. Which is basically two things, but the most important part of its functionality is it gives you a way of executing ink contracts without spinning out a chain. So this way it's extremely fast and super good for prototyping, for rapid development. So you can use it as a library, for example, in your end-to-end tests. I think it's also going to become one of the possible backends for the end-to-end tests so that they run real fast. And the other thing that you've just seen on the neat screencast is it has like a CLI or like a text-based interface that, well, basically allows you to interact with the contracts in a quite interactive way. And definitely check this out. It's quite awesome. Very fast, very convenient. Yeah, and you actually won't need any other dependency besides Rust to run it, because it doesn't even, well, it doesn't even use cargo contracts. It has all of the goodies bundled inside. Okay, I want to. Oh yeah. So thank you. It was a pleasure to talk to you. And if you want to scan the QR code, it's something that one of our teammates once created. It's like a kind of an assignment or like a smart contract scavenger hunt, if you will. Yeah, that's gonna help you, get really good at analyzing contracts and interacting with them. There's no prizes, but it's a good learning experience. Okay, so thank you. That would be it.